Okay, solve the equation. Okay, we're going to mix some ones where we have to use linear properties and ones where we have to factor. So if I see I have to solve for a letter and that letter variables inside the square root, there's two steps. We need to solve for the square root, and then we need to solve for our x. Okay, so square root's here. Well, we have a number outside the square root. It's times 5. So we would get rid of the times 5 with divide by 5 before we do our second power. Okay. So divide by 5, and that's 3. So the square root of 3x equals 3. Now you do your second power so that we get rid of the square root. Okay. So 3x. Now, this is a number, I don't have to get rid of the exponent and duplicate it, okay? I know that's just 3 times 3, and that becomes 9, okay? So that's a good thing. So now it's time to solve for x. Well, we got x only, so that's the linear properties side of things with one answer. So we have a times 3, you just need to divide by 3, and that's 3. And again, the reason why that works, because here's the original equation. If I substitute that solution of 3 in for x times 3, again, so I'd figure out my square root, that's 9, and then the square root of 9 is 3, okay? So we have 5 times 3 equals 15, which 5 times 3 is equal to 15, so that's checked. Okay, now in my next problem, the square root of 3x plus 10 equals 8, okay? So, 1 and 2. Solve for your square root, then solve for your x. Square root, there's nothing outside the square root, nothing at all, so we go right to the second power. There are no operations outside of the square root. So the second power frees up the square root, and we now have the expression 3 times x plus 10. 8 to the second, you don't have to duplicate it. You can just take 8 times 8, that's 64. And now I solve for x. So again, it's x only. We would use the linear properties model. Okay. So we got times 3 and plus 10. So we subtract 10, and that gives me 54. Then we divide by 3, and that's 18. So far, so good. Okay. Next one, the square root of negative 2x plus 3, and then after the square root has ended, we have a minus 2 equals 10. Okay. So, same name of the game is the same thing. Solve for your square root or your radical, whatever you want to call it, then solve for x. Okay. Okay, so the square root's on that side. Now we do have a number outside. One number, it's a minus 2. How do you get rid of a minus 2? Well, you plus 2. Then you get rid of your square root with the second power. So plus 2 first, and that's 12. Now second power, do exactly what you wrote you were going to do. So we have negative 2x plus 3. 12 to the second, that's a known value, it's a constant. You take 12 times 12, and that's 144. Okay, solve for x now. So you have x only, and you're using the linear properties method because anytime you have the variables to 1 degree only. Okay, minus 3, that's 141. And then divide by negative 2. 141 divided by negative 2 is negative 70.5 or negative 70.5. It doesn't matter. Okay, there you have it. Okay, now the next one. Still the same thing. It's the same line of thought, even though there's two of them. You solve for your square root, Now, I don't really have a side to go off of because it's on both sides, but there's no operations outside of the square root anywhere. So I go right to my second power then. But what happens then is, since there's a square root on both sides, all that happens is we get cancellations on both sides, giving me 4x plus 1 on this side, and then x plus 10 on the other side. Okay. Now, solve for x. Now, there might be two x's, but they're both to the first power. There's not any x to the seconds. It's just x only. So linear properties. You just got to do a little bit of work before you make your line because you have x on both sides. We'll just take out the smaller one. Okay. So it's 3x plus 1 equals 10. Okay. Now you subtract the 1 to get 9. And then divide by the 3. And x equals 3. Okay, and again, the reason why this works the way that it does is I will put that 3 in for x on both sides of the original equation. So we're going to have 4 times 3 plus 1. I'm putting the solution in for the x. Then 3 plus 10. So 4 times 3 is 12. 12 plus 1 is 13. So you got the square root of 13. And then 3 plus 10 is going to be 13. Square root of 13 is irrational, but I mean it's on both sides, so that's a check off. That means I did it right. Okay, next problem. X minus 6 equals the square root of 3x. So you solve for your square root, and then you solve for your x. Here's the square root side. There's nothing outside. You go right to your second power. Okay. Okay, so the side with the square root cancels and we have just 3x. Okay. But on the other side, we can't take just the thing to the second power because we have a letter in there and we don't know the value of the letters. So when that happens, you get rid of this, you make another parentheses just like it, and you put x minus 6. Sorry, you can't see that. X minus, that's what you do when there's a variable inside. Because you can't take it to the second power because you don't know what the heck the value is. So then you take the expression and write it twice. X minus 6 times x minus 6. Put the 1's in front of the x's. And that's a binomial, a 1 multiplied by a x and a negative 6. And the other one's the same thing. So that's binomial. So you have to FOIL. Okay. So 1x times 1x. 1x times a negative 6. And then negative 6 times a 1x. Negative 6 times a negative 6. So 1x squared, negative 6x, negative 6x, 36. Okay? So x second, x constant. So you have 1. Negative 6 plus negative 6 is negative 12, and then 36. So that's your new trinomial. Okay, now when you solve for x, you're using a different set of rules, different set of properties, because the x you have to solve for is to the second, but it's also to the first. So that's factoring properties. So there'd be two answers. Okay. So you need to clear the side without the x second. So you'd subtract 3x, and you got this negative 12 also multiplied by just x, so there you'd have it. So x second, x constant. So you got 1, negative 12 minus 3 is negative 15, and then 36. Now you see your trinomial that you need to factor. So GCF and table. Basically, when you factor, you're figuring what parentheses, what two binomials multiply to get this trinomial in the FOIL. Okay, so ABC. 1 times 36 is 36. That's positive, so it's got to be a match. And it's got to add to negative 15. 1 and 36, that's negative 37. Divide by 2 is 18, that's negative 20. Divide by 3, you get 12, and there's your negative 15. Okay, so negative 3, negative 12. So the A is 1x to the second. Okay, 1 and 3, that's only divisible by 1. Same thing here. Take the 1's off the front, and it's x minus 3 times x minus 12. So you add 3 to both sides and you get 3. Then you add 12 to both sides and you get 12. 3 and 12. Okay, x minus 10 equals the square root of 9x. Okay, so again, solve for your square root and you solve for your x. Okay, square root's on that side of things, nothing going on outside, so we go right to our second power. Cancels out. This does not cancel. Okay, the only time it cancels is if you have a square root and a second power. Okay, so the second power, yeah, but you don't know, you can't find what the value is of the second power because you got an x that is unknown. So then you make another parentheses just like it with x minus 10. And again, you have another binomial times a binomial. So 1x times 1x, 1x times negative 10, the FOIL method. Out, negative 10 times 1x, negative 10 times negative 10. Okay. 1, negative 10 plus negative 10 is negative 20, and then 100. Okay. Okay, now it's time to solve for x. You got x second, you got x. That's factoring properties. Okay, so you're going to clear this side because that's where the x second is not. And that 9's multiplied by x, the negative 20's multiplied by x. So when I minus the 9x, it can be under the negative 20x. So we got x second, x, and the constant. 1. Negative 20 minus 9 is negative 29, and then 100. So GCF. And the old table. No x, no negative, 129. When 1's in there, you know it's 1. Okay. 1 times 100 is 100. That's positive. So that's a match. And you're like, oh, can I go to the quadratic formula? Oh, no, it's over 100. We go to the quadratic formula, not right at 100. Okay. It's got to add to negative 29. So 100 divided by 1 is 100. That's negative 101. Way too extreme. 100 divided by 2 is 50. That's negative 52. That's too extreme. 100 divided by 3 is a decimal. How about 100 divided by 4? Well, that's 25. Okay, and those indeed add to negative 29 right there. One x second, so x times x. 1, 1. Now again, those can't really do anything. So take the 1's off the front of the x's. Because when I go to solve, I don't really need the ones. You can keep them if you want, but yeah, not really going to change the answer when you divide by 1. So x minus 4 could equal 0. X minus 25 equals 0. So I add 4, I get 4. Then I plus 25, I get 25. 4 and 25. Okay, we have x equals the square root of 16x plus 225. I'm actually going to cross that one out and not do it. Okay, the square root of 14x minus 3 equals 4x. The t-chart takes forever on that one. Okay, so solve for your square root. Solve for your x. Square root, you just go second power. That side cancels, giving me 14x minus 3. And again, we have this problem where we have a variable inside, so all we can do is duplicate the expression. And this isn't a FOIL. This is just 4x times 4x. It's not a binomial. It's just a single term times a single term. So 4x times 4x, that's 16x second. Okay. Okay, now in this problem, so again, and if it was just x like this one is, it'd be 1x. Okay, you just put a 1 in front of it. Okay, time to solve for x. So we got x second and x, so that's factoring properties. 2 answers. Okay. You want to clear the side without the x to the second, so subtract 14x. Now 14x, there's no number over there multiplied by just x. There's a number multiplied by x second, but not x. So minus 14x, hang it. Then plus 3, hang it. So you turn this around so the zero's over here, okay? And then you can always turn an equation around, okay? And equals is an equals. It doesn't matter which is on each side, okay? Okay, so 16. Negative 14, and 3. So there's my 3 terms. I'd go GCF, and then the old table. No x, no negative. 16, 14, and 3, ironically, are only in the first row. They're not in the third row. 3 doesn't go into 16 and 14. Okay, 16 times 3 is 48, so positive, it's got to be a match. And this match has to add to negative 14, so we know it's a negative negative. 148 ain't it. 48 divided by 2 is 24. That's negative 26, so that's not. 48 divided by 3 is 16. That's negative 19. 48 divided by 4 is 12. That at negative 4, negative 12 would add to negative 16, so that's too extreme. 48 divided by 5 is a decimal, and 48 divided by 6 is 8. Okay? So I add those, that's negative 14. So A is 16x to the second, so x times x. And then we will be applying 16 in front. Now this doesn't stay 16, it divides, okay? 16 and 6, that would be in the second row. Greatest common factor there is 2. 16 and 8, the greatest common factor is 8. 2, it's in 2's row, it's in 4's row, but it's also in 8's row. So it's going to be 8x minus 3, and that's going to be 2x minus 1. Again, the number at the end here, the numbers in front of the x's, 8 and 2, should multiply to the x second term. 8 times 2 is 16, shazam. Negative 3 times negative 1 is positive 3, so I did this right. Okay. So 8x minus 3 times 2x minus 1 equals 0. So F1, F2. So I add 3, and I get 3. 3 divided by 8, you can write 0.375, or you can leave it as 3/8. It doesn't matter to me. Okay, and then over here, plus 1 plus 1, 2 times x equals 1. 1 divided by 2 is 0.5, which you can write, or you can second PRB it and leave it as a fraction, 1/2. Doesn't matter to me.